Hello and welcome to another edition of Your County at Work, where we bring you to the front lines of hardworking men and women of Newcastle County government. Today I am here at Woodard Farms 1 in Odessa, and we're about to go inside and speak to Regis.
Hi, thanks Wayne. And my name is Regis Yursich. I'm an engineer in Special Services in charge of the plant operations section. And we're here at our MOT wastewater treatment plant. We're going to give you a tour of our facility. This is the county's largest wastewater treatment plant. But before we get into the actual details of the plant, I'd just like to go over a couple things to kind of put it in context. Plant operations also does all the pump stations and force mains for the county, and we do both north and south of the county. This is a map of the north of the county, and all the green squares are pump stations. And all these pump stations up here all flow to the City of Wilmington wastewater treatment plant, which is located on 12th Street in Wilmington. The county has only one wastewater treatment plant north of the canal, and that's here at Delaware City, and it serves this area here of Delaware City and North St. George's. Moving south of the canal, we service the pump stations, the treatment, of the entire unincorporated area south of the canal. We have three wastewater treatment plants south of the canal. We have a small plant in Leera, which serves the Summit Farms area and Leera Farms community. We have another small plant at Port Penn, which serves the city, the Port Penn town, and it comes down through to Bayview Beach. And then we have the plant we're at here, which is the Water Farm 1 or MOT wastewater treatment plant, which is our largest facility. And it serves everything else here, all the way around from Townsend and up through to the Odessa area. So that's the basic overview. We'll zoom in a little bit. This is our treatment plant, an aerial of our treatment plant that we're at right now. And it's a fairly large lot. It's about 330 acres. And it has some lagoons and spray fields. So our plant here at MOT has a spray irrigation discharge where we take the treated effluent and we spray it onto a crop, a hay crop. And we also have a stream discharge that we discharge into the Appoquinimink River. The plant was commissioned about 1995. It came online, and it was strictly a lagoon treatment facility. Lagoon treatment facilities, this view here will show you a little bit about the lagoons. The lagoon treatment facility is a treatment method where the water comes into the first lagoon, sits there for a period of time, moves to the next lagoon for a period of time, into the third lagoon. It's a natural treatment process, and it's really based on time. So you need a lot of time for that water to go through those lagoons, to have residence time in those lagoons for the biological activity, to get to a finished product, a finished effluent product, which is suitable for discharge or irrigation. As an example, this treatment plant was designed, we were talking about from one time when a drop of water enters that first lagoon, it's between 35 and 40 days before it gets to our final lagoon, and that's basically the time you need to treat that water. The lagoon treatment process has some negatives to it, and we found that out later, probably around the year 2000, when the state of Delaware enacted some more stringent requirements for us to go to the river, to discharge to the river. Around that time in 2000, EPA in Delaware, they had started to address the impaired waterways in the state. And nearly every waterway in the state is classified as impaired, which means it's not suitable for every possible usage, fishable, swimmable. So there's efforts made to clean up all the effluent, all the water that gets into those waterways. And part of that cleanup required us to enhance the treatment process at this facility. So in 2005, we commissioned a mechanical extended aeration plant here called a SBR, which stands for Sequencing Batch Reactor. It's a mechanical plant that provides a much higher level of treatment, a much more controlled level of treatment that gives us restores our ability to discharge to the Appoquinimink River. So with the lagoon treatment process, we almost had to stop discharging to the river. With the enhanced treatment process, we were able to restore our discharge and keep going to the Appoquinimink River. So I have a couple of charts here that just show you the changes from 1995 to 2005, and this is really the present condition that we're in right now. In 1995, we had a capacity of 1.7 million gallons per day here. We have a large site of 330 acres. I have about 150 acres being spray irrigated. We have 3 large lagoons. Lagoon number 1 holds 17 million gallons. Lagoon number 2, 49 million gallons. Lagoon number 3, 103 million gallons. We grow a reed canary grass crop. We spray on that all summer and then cut it and get rid of it and use it as the commercially use. Our stream discharge was 500,000 gallons a day to the Appoquinimink River. So we had 1.2 spray and 0.5 stream. So with the enhanced, more stringent requirements to go to the stream, this number was essentially going to go to 0, and without not allowing that to happen, we enhanced the treatment facility with the SBRs, and we actually increased a lot of the numbers, other numbers also. So we now have a treatment capacity of 2.5 million gallons per day, but we only have an ability to dispose about 1.83 million gallons per day. We could spray 1.33 million gallons. We now have about 170 acres under spray, and we still have restored our stream discharge. We've reused the lagoons from their original process. Lagoon number 1 is a flow equalization lagoon. So when flow comes in here and peak flows come in here, it can go into that lagoon and be stored until we're able to get it to the SBR. Lagoon 2 is biosolids or sludge storage, which is sort of the use it was in before. The sludge, it has to go somewhere and it's stored at the bottom of the lagoon and undergoes further treatment. And lagoon number 3 is our stored water. The key points of the upgrade is we have a far superior treatment. We're now using the best available technology for the treatment process. We're 10 to 25 times better than it was with just the lagoon treatment. We've restored the stream discharge capacity. We've reduced the pollutant levels to the spray fields, which allowed us to expand the spray fields on our own site where we didn't have to have buffer zones and distances between our spray and property line to meet the EPA requirements. Our spray is now considered public access, suitable for public access. It could be the water treatment is high enough that it could be sprayed on golf courses or lawns, etc. It's a far more reliable, adjustable, and controllable process. And we have the ability to double the treatment process fairly easily here to take this plant to 5 million gallons per day. So what we've done with this lagoon process, shown 1, 2, 3, that process is essentially changed, has been replaced by this process right here, which you're going to see later, which is the SBR process. And from going from 35 to 40 days, it now takes us 6 hours. So we've enhanced, a lot of the features here. We have current technology on the discharge, and we're very happy with the performance. As far as staffing of this plant goes, we have, for our 4 wastewater treatment plants, we have 3 operators and 1 senior operator. All our operators are licensed with the state of Delaware. They're responsible for the plants 365 days a year. They have to visit the plants 365 days a year. So we have a good dedicated staff that operate these facilities. Our other remaining staff who operates the pump stations also assists with maintenance here, does most of the major maintenance at these facilities, at the treatment plants, and are available to come in and assist whenever these guys require. So we have a very good staff, and we have a very strong record of compliance with the regulations and our permits with the state. That's my overview, and I'm going to turn it over to Brian Blackburn, who's our senior operator, to walk you through the facility. Thank you.
Thank you, Regis. My name is Brian Blackburn. I'm the senior operator for Newcastle County. We're here at the MOT treatment plant. This is the Headworks Building. This is where our wastewater that comes in gets screened. So basically anything that comes through the sewer line, it could be plastic, rags, basically anything that somebody could flush down a toilet will actually come into this building, and we have a series of screens in there that'll screen out and clean the water through the process and then send it down to our sequential batch reactor. So this is our parks and screens. What it does is it has a head box. The wastewater comes in through here. There's a head box that runs 3/4 of the way down the screen. And in that head box there, grits and sand will settle out. As the wastewater goes over the sides, there's an internal drum that's spinning. It has a series of fins on it and slots inside the screen where the water will percolate through that. So any sand, cinders, plastic, rags and all will get pushed down the end of the screen and go through an auger at the end and out into our dumpsters. The wastewater will go through there. It's called gray water because it hasn't been treated yet. We'll go through the bottom of the screen, down through a secondary bar screen, and into our sequential batch reactor for treatment. So as Regis was saying earlier, before we put on the sequential batch reactor, we were a Lagoon System plant. So this is would have been our primary lagoon. That lagoon over there is our secondary lagoon. And the big lagoon on the roadway in was our spray lagoon. Currently now with our sequential batch reactor, this is more of an equalization lagoon. So like Regis said, if we have high flows coming through, we could actually back feed it into this lagoon and step it through our process so we can maintain our high quality of effluent. So now we're at the sequential batch reactor. It's the acronym for SBR. It's a type of treatment that's done all in one tank. At a conventional plant, you'll have your aeration, your clarifier, and your settling tanks. But this is all done in one tank. It's all done on either a timer or levels. So what will happen is the wastewater will come through that tank over there. A line will be underground, come into the tank, and you'll go through, the first stage is actually called a mix fill. What will happen is you'll have the mixer on, and that'll actually start turning up all the biomass at the bottom with all the new incoming wastewater. So the microorganisms will start breaking down, the wastewater. And after that stage, it goes into what's called a react fill. Now we'll start adding air. We'll still have the mixer on. We'll start adding air, and then we'll start going through our nitrogen or nitrification, denitrification series by converting the ammonia nitrogen to nitrate and then changing it to nitrate. After the react fill stage, we'll go into react stage. So what will happen is with this sequential batch reactor, you have a certain level that the tank gets to, and that's considered your batch. So the lowest level will be at 17.1. So if it's up to 20 foot, then you got about a 3-foot batch in there. So in the react stage, what you'll do is you'll get further breakdown, kind of like a polishing of your BOD and your TSS. And then we'll start actually adding alum so we could break down our phosphorus more. And then after the react stage, it'll go into a settle. The basin that we have online is actually in a settle. So what will happen there is you'll have nothing going on with the wastewater, so the solids will settle down, and you'll get a clear liquid on top, which is the supernatant. And then the next stage is a decant. So that piece of equipment over there is the decanter. What will happen is there's a weir plate on the bottom. It'll open up, and it'll start drawing off the clear liquid, sending it over into our post-equalization tank, and from there it'll be fed in through our filters and disinfection. So this right here is our digester. So as you can see, we have mixers in there just like over in SBR itself, and we also have air going into the wastewater there. Now this is our digester. So what happens as your biomass is breaking down waste, it's actually recreating new biomass. So what we have to do through a series of tests that we do is we have to judge the exact amount of biomass we need to give us our best treatment. So what we do is we actually have to cast off some of that, which is called through wasting. So this is extra sludge that we generated that we'll put into this basin. We'll have the mixer going and have the air going, and what that'll do is that'll actually start starving the biomass, and it'll actually turn on itself and start breaking down itself. So we'll have it in this tank for about a month, and then we'll actually pump that over to our previous #2 lagoon, which is our biosolids polishing pond. So this tank is just to show you that we, what it'll look like when it has the air going on and the mixer running. This tank right here is our post-equalization tank. All this is when the SBR goes through a decant, it decants at 1,600 gallons per minute. What we want to do from this stage is we want to feed our filters as slow as possible so that we get the best filtration. So through this tank, it's basically a storage tank, and then we could step feed our water into our next section of our process. This water right here has already been treated. It has not been gone through our filter process, and it has not gone through our disinfection process. But what we do in this tank is we just slow it down so we can control our filtration and our disinfection through the next process. All right, so now we're inside of our building where we go through our filtration and our disinfection with ultraviolet. And this is where we also do our daily test for our permit. So from the filter and the disinfection and the PLC, we're going to send it over to Ronnie. His name is Ron Pequer. He's our level 4 operator down here. And he's the one who normally runs this section of the process.
Hi, my name is Ron Pequer. I'm the treatment plant operator of Newcastle County at the MOT treatment plant. And I'm going to take you through a couple of the processes that we have in the section that I'm responsible for. This gives you an idea. This is a test that we do. It's called a SV30. It's a 30-minute settability test, and it shows you the condition of your biomass, which is the important thing that reduces all the sludge and all the waste that's in wastewater. This is after 30 minutes, and this is all the clear water up here, and this is your biomass that settles down. So this gives you a sense of the condition of your biomass. This water here, right now the plant is in settle out there. The plant is in settle out there. After 30 minutes of settle time, actually it's an hour, after an hour of settle time, this water is decanted off into the forward feed EQ tank. And from the EQ tank, it is pumped into here to our filter media system. Okay, these two units are our cloth media filter systems. These are the final process before the wastewater runs to the UV system. Now these two media systems are going to be in the process of being upgraded. The way they work is they have discs. The cloth media is stretched across these frames. The cloth media is stretched across these frames. These frames are mounted on a metal drum. The wastewater comes through, the particulates and the solids are trapped on the outside of the cloth. The clean water passes through the cloth into that drum, and this is the clean water, and it comes over this weir and down to an after bay. Now we have both of these online. These are going to be in the process of being upgraded for more capacity. Right now they're running at half capacity, but we're going to put them up to full capacity. So they're both online. The drums go through a system of self-cleaning and wasting of sludge. In other words, they have a timer on them where they backwash water and they clean off the filtered media, and also they have a timer that gets rid of the solids that lay on the bottom of it, and the solids are pumped back out into the digester, where the clean water is bled off and put down into the UV system. This is the control panel for the cloth media filter system. And this gives you a readout. It tells you what it's doing and the timing and the depth of the water that's in there, and where you can scroll back and forth, and it gives you a history of what's going on with it. If there's a problem with it, it tells you what the problem is. So this is just a reference of what it's doing. This is our UV channel system. We have two UV channels. This is ultraviolet. This is for disinfection. So what it does is the wastewater comes out, but before it can be released, it has to be disinfected. And any pathogens that are in it are run through an ultraviolet system. Through this channel, and it's treated with ultraviolet. Now what the ultraviolet does is it removes the ability of the pathogens to reproduce. So when they go out, they can't reproduce. This is once they die, and that's it. And we have incredible results with this. Before we used to use a chlorine system, but chlorine's dangerous, it's costly, and it's just going out of phase. So most treatment plants are going into the ultraviolet system. It's clean, it's economical, and it does a great job. This is the after bay past the chlorine system. It goes into these two finger channels, and the finger channels, what they do is they keep the depth of the water constant, and then they cascade over slightly, so any kind of solids or anything that may have gotten past the filters will settle out in here, and this is periodically cleaned. When the water then cascades over, we have two gates here for two different discharges. This is the lagoon discharge, and over there goes your point discharge, which goes out to the Appoquin River. Now right now, we have the lagoon sealed off, and we're getting our lagoon level down so that we can eventually turn off the flow to the Appoquin River for a while and just spray. And this is the outfall that goes to the Partial Flume. These are called Partial Flumes, and what they do is they have a depth gauge on them that measures the flow through depth, and that goes back to our totalizer in the SBR building that gives the total of flow for the day. As I said, this side discharges, this side over here, which is off, discharges into the lagoon, our storage lagoon, and this side discharges into the Appoquin River. This is our motor control center. This is where all the controls are that run everything in here. These are the two panels for both SBR units. This is the PLC readout that shows us the depth. It shows what's running. It shows the DO level. It shows the aeration time mode, and you can set everything for your timers. They all can be set through this panel. These are your blower controls. That is run with blowers. In fact, we'll go into the blower room too, real quick. These are your pump controls and your mixer controls. And these are all the banks for all the shutoffs and the disconnects for all of that. This is the blower room. This is the blowers that produce the air for the entire process of aeration. Right now we have one offline that's going to be sent out for repair. We have 4 blowers. We stagger them in use. We have blowers over here for the EQ tank, which is the tank where the SBR drains off into, and then it's pumped into here. And these are blowers for the digesters. And the important thing of the oxygen is the oxygenation helps to degrade the sewage, and it keeps the odor down. It's relatively odorless here. And it's the integral part of wastewater treatment, especially aerated wastewater treatment. And so we go back to Brian.
Okay, now we're out into our spray fields. Like Regis said earlier, we are able to spray about 1.33 million gallons a day. We have our center pivots over there. We have 5 of them. And then in the dead spots that we have between pivots, a couple years ago we put solid sets. So that brought our total irrigated area up to about 170 acres. We have our center pivot number 2 over there is the only one that does a complete circle. All the rest have stops, so they'll just run to that stop and then come back. We usually spray about 7.5 hour days. We'll usually start spraying about mid-March, and we'll spray all the way through till around Christmas time if the weather's favorable. As you can see, our spray fields go out around the edge of those tree lines, and we have 2 more spray fields back there and 3 more solid sets. That's it.
That brings us to another conclusion of Your County at Work. On behalf of County Executive Thomas P. Gordon and the entire NCC TV crew, we'd like to thank you so much for tuning in. Please make sure that you go to your Facebook page and like us.